Hello and welcome to today's presentation. Is someone tampering with your iOS application? Today's presentation is being brought to you by Whitecryption. Before we begin today's presentation, please note that the slides for this presentation will be pushed to your screen automatically, and the audio will be streamed to you through your computer. With that said, it's now my pleasure to introduce our speaker for today. Joining us is Marko Kaklovic. Marko is a software engineer at Whitecryption with responsibility for the Cryptanium code protection solution, where he specializes in software reverse engineering and protecting software against hacking. Now let me hand things over to Marko to begin his presentation. Please go ahead, Marko.
Okay, thanks, Don. Hi, everyone. My name is Marko Kaklovic. I'm a software engineer at Whitecryption, and today I'm going to demo for you Cryptanium code protection. So basically what Cryptanium code protection does is it protects your application against tampering and reverse engineering. The way it does this is it takes the source code of your application, it inserts obfuscation and security code into your application to make it harder for hackers to hack into your app and tamper with it. Today I'm going to show you how to use our tool to protect a small open source application called Onions. I got this application off of GitHub. It's open source, anybody can download it. And pretty much before we begin, I just want to show you what Onions looks like. So basically Onions is a small application to store your notes securely in the cloud. So you can register an account, which I will do right now. And after you've registered, it takes you to the screen where you can create what it calls onions, which are small notes. And these notes are encrypted locally on the phone before being saved in the cloud. So basically what this means is whenever you're storing anything on a remote server, it's encrypted on your phone locally, so the remote server will never see your content. Now the problem with Onions is the app is completely unprotected. So for example, if there was some malware on this device, it could hook into the app and steal the encryption keys from memory, or hook into the decrypt function and steal the plain text from memory before, after it's decrypted or before it's encrypted. And also, the app is very easy to reverse engineer, which I'll show later. So basically, I want to show you how we can protect this app with Cryptanium code protection, so that it's not as easy to reverse engineer, and so that it's protected against tampering. So right now I'm going to start Cryptanium code protection on my machine. And the very first thing when you start code protection is you see this screen. So basically code protection organizes everything into project files. It does this in order to keep track of where your source code is and what security settings you apply to your source code. So I'm going to go ahead and create a new project. Cryptanium code protection supports a wide variety of platforms. As you can see here, we have Android and iOS and OS X. We also have Windows and Linux, but however, since this is a Mac, you can't really build Windows and Linux applications for it, so that's unavailable. And we also have a custom option, so if your platform isn't listed here, we give you instructions on how to integrate our tool into your build chain so that you can easily use it to protect and obfuscate your applications. So today I'm going to be protecting this iOS app called Onions. So I'm going to select iOS as the target platform. And then code protection just asks me to save the project file somewhere. So I'm going to do that now. And basically the very first screen you see is called analysis screen. So before code protection can begin working with your project, it needs to know where the source code of your project is. So the very first thing you need to do is you need to select the source root of your project. What the source root of the project is it's basically the topmost folder under which all your source files are located. So I'm going to just select this folder, Onions iOS Master. This is the folder I downloaded off of GitHub to get this application. So I just click Choose here. The next thing you need to do is you need to select the Xcode project or workspace. So if any of you have ever developed an iOS application before, you will know that everything is organized by Xcode into something called an Xcode proj or an Xcode workspace. These files keep references to all your source code and also contain compiler settings that Cryptanium code protection needs to read in order to work. So I'm going to select the Xcode workspace right now. And in order to speed up this demo, I'm just going to exclude third-party dependencies from being protected today. So we're just going to protect the application today and not any of its dependencies. So once all of that is done, all you have to do is click Analyze. And what happens now is code protection invokes this Xcode workspace file. It tells Xcode to compile it. And while Xcode is compiling, code protection basically reads all the source files that Xcode is working in with. And as you can see here, it's analyzing those source files. So what this means is code protection is right now reading the source code of your application. It's making sure that it can parse the source code of your application, that it can read everything correctly. And once that's done, we're ready to go on to the next step. So as I said before, the way code protection works is it works by inserting security code into your application and by obfuscating your application. Now, if you have an application that has a lot of performance-critical functions in it, such as a video game, you don't want very performance-critical code inside the video game to be obfuscated or protected because that will slow your video game down. So with code protection, what we offer is something called profiling. Profiling is very interesting. What it allows you to do is it inserts special profiling code into your application, as you can see here. And what this profiling code does is it allows you to run your application, and while the application is running, it will send information back to Cryptanium Code Protection. What happens when this information is sent back to Cryptanium Code Protection is we collect statistics about the runtime performance of your application so that we understand what parts of your application are sensitive and what parts are not. What parts of your application are performance sensitive and what parts are not. And using that information, we can insert security code and obfuscate your code in a really fine-grained manner without affecting the performance of your application. So what I'm doing right now is I clicked Build Profiling, and what Code Protection has done is it's inserted the bunch of profiling code into your source code, and then it's going to build that source code right now for you into a binary. And what happens is we will then ask you to run that binary on your phone. And as the binary is running on the phone, Code Protection will collect performance statistics about the app. So it's built the app right now, and I'm just going to deploy it to the phone. So I'm just going to exit this app right now, and I'm going to deploy the new version to the phone. Okay, so now the special profiling binary of the application has been deployed to the phone. I'm going to just click Start Profiling here. So that means Code Protection will open a socket and start listening for profiling information from the application. And then I'm going to run the application. And as you can see here, it says it got a connection from the phone, which means it's now receiving profiling data as the application is running. So right now, you just want to run the application like you normally do. And as the application is running, it's silently in the background sending information back to the computer about what functions are getting executed, how much they're getting executed, what's happening right now. So basically, I'm just using the application like I normally would. I'm creating the nodes. I'm logging in. I'm logging out. And when I'm done, I'm just deleting this account. And so basically you should just spend a few minutes, use the application like you normally do, and as you're using the application, Code Protection will be collecting information about the application. So when you're done with that, just close the application, and Code Protection will tell you, okay, we've detected you closed the application, and we're done profiling. And so the final step is protect. So in this step, what Code Protection will do is it will take the source code it collected from the analyze phase, it will take the profiling statistics it collected from the profiling phase, and it will insert a protection code and it will obfuscate your code to make tampering harder. And so right now all you need to do is click Protect, but before I do that, I want to show you the various options we have. So I'm going to go under Advanced Options. So over here, we have a bunch of sliders you can use to tune how much you protect your application. We also have the option for you to insert debug logging into your application to be able to track down problems more easily. We also have the ability for you to call certain functions in your application when you detect the application is being hacked. For example, if you detect that somebody has attached the debugger to the application, you can specify a function to be called, and this function can, for example, send an email to an administrator letting him know that somebody's trying to hack into the application. And we have a lot of really tunable advanced security settings here, such as anti-jailbreak checks or anti-swizzling protection. I'm going to turn them off now so they don't interfere with the demo. And I'm going to just turn on these security features here right now. And so basically, you have a lot of control over how much your app is getting protected and what parts of your app are getting protected. And I encourage you to explore that if you ever should evaluate our product. So I'm going to just click OK here, and I'm going to click Protect. So then what's happening right now is code protection, like I said, is taking the source code that it got from the analyze phase, and it's taking the profiling statistics it got from the profiling phase, and it's just inserting security code into the application right now and obfuscating it. And when that's done, it's just going to build the application for you. So at the very end, what you're going to get is a protected binary that you can just deploy to your phone to test or submit it to the App Store. And this binary will be protected against tampering. And I'm going to demo that as soon as it's done building here. Okay, so the protected version of the binary has been built, and now all you have to do, like I said, is either submit it to the App Store or deploy it to your phone, to the phone to see how it works. So I'm going to deploy it to the phone now. Oops. And then you can just run your application like you normally would. And as you can see, nothing has really changed about this application. It's still the same old app that you saw before. And that's because what's changed in the application is not visible to the end user. It will only be visible to any hacker that actually tries to hack your application. So, you can just use the application like you normally do. And everything should be okay if you're a regular user. But let's see what happens if you're a hacker. So this is a jailbroken phone right now, so I can actually go and log into it via SSH. So, whoops, I'm going to go ahead and do that right now. So I'm going to say SSH to root at 1.258.127. So now I've logged into the phone, and I can run GDB. So for those of you that don't know, GDB is the GNU debugger. It is basically the debugging application that hackers usually use to hack into applications. So in this case, I'm going to try attaching GDB to the protected Onion app. And basically what's happening right now is GDB is just attaching to the application, and it's reading stuff. So hackers would use GDB to attach the application to observe its behavior at runtime, to modify parts of the application, or to, for example, dump application memory, or just dump the application itself from memory in order to pirate it. So we're just going to tell GDB to continue running like it normally does, and then we're going to go back into the phone and try to log in. And as soon as I clicked the login button, what happened is GDB detected a crash inside the application. And no matter how much we try to continue, the application just won't run. What's happening right now is that the Cryptanium code protection detected that GDB is attached to the application when somebody tried to log in, and it just blocked GDB from working. It crashed the entire application. So as you can see here, if we try detaching GDB from the application to let the application continue running, the application just crashes. It's detected that it's trying to be tampered with, and it has reacted. So that's basically what it looks like when you try to debug a protected application. I'm also going to demonstrate to you how it looks like when the application, how the obfuscation of the application looks like to the hacker. So here I'm in remote control of a Windows PC that is running a hacker utility called IDA Pro. IDAPRO is pretty well known. It's used to deep compile just about any application out there. It's very popular amongst reverse engineers. Here to the left, you see the unprotected application of Onions. Note how here on the left, all the Objective-C metadata is present. So you can see, for example, all the functions and the parameters of the functions. So for example, if I do Control F here, I can search for sensitive functions such as decrypt text. And IDAPRO is very intelligent. It's able to tell you like what class decrypt text is part of, what the parameters are. And as you scroll down here, you can see that it is able to decode the Objective-C messages. So for example, decrypt text, we can see that it's taking the password from the session, and then that it's base64 encoding the password, and then it's later using that base64 encoded password in order to calculate a key and then decrypt the text. So this is very useful information to the hacker. He can from this be able to derive the decrypt function. Or for example, he would be able to hook this function with GDB and dump text or data as it's being decrypted. Here to the right, we see the protected application. So notice how all the Objective-C metadata that is present here on the left is not present here on the right. And also notice how instead of seeing constants for Objective-C messages, like here's an Objective-C message sent, but you don't see what kind of message is being called like you do here. That's because if you guys can read machine code, you will see that the message is being decrypted on the stack right before it's being used. So basically we encrypt strings, we encrypt Objective-C metadata, we encrypt the strings that point to Objective-C message names before they're used. We use also a lot of obfuscation in order to make the application harder to statically analyze. For example, here on the left, we can just see what the function looks like normally. So this is basically how a regular function looks like inside a regular program. You have a prologue, you have an epilogue, you have a function body and the loop. And IDAPRO is able to disassemble all that and show it to you very nicely in a nice little graph. But here on the right, we will see that since we've obfuscated the function, that it's very hard to tell what the control flow of the function is. Everything has been flattened to one level, to one big switch statement. So as each block of the switch statement executes, it just returns to an initial block. So basically, we've totally perverted the control flow of the program and obfuscated it and made it very hard to understand what the program is doing. And that's about it for today. So I've just demonstrated to you how you can use our application, our cryptanium code protection application to protect your iOS app. I've showed you what it looks like when a hacker tries to attach a debugger and debug the protected app. And I've showed you what it looks like when a hacker tries to disassemble the application. And I guess that's it for now.
Okay. Well, thank you, Marco. We're now going to move on to the Q&A portion of today's webcast. We do have a few questions that have come in for today. And the first question that we have, this person would like to know, how do we debug a protected application?
As I demonstrated, it's very hard to debug a protect application because debugging is something a hacker would do. So we generally don't allow you to debug a protected application. Of course, you can turn the anti-debug features on and off, but we actually recommend that you leave those enabled for better security. So we recommend that you use logs to log as much as you can about your application in case of a crash, or that you use the crash dump of applications to figure out where a crash happened.
Okay. But what if the protect application's performance is too slow?
Well, in that case, we have a bunch of different features called security groups. So over here, we have function groups. For example, you have a default function group, but you can add more function groups, such as I'm going to add a function group called test. And then you can mark the source code of your application with a pragma that tells it to use the test function group. and then you can dial down the security settings for this test group, for example. So you can mark different parts of your application with different pragmas in order to have different performance. You can also exclude parts of your application. For example, here I excluded pods, which is the third-party dependencies of the Onions application. So when you exclude the dependencies of the application, the performance will be a lot better because those parts of the application are getting protected. So generally, there's a trade-off between security and speed. You need to be able to protect the critical parts of your application, but if something's not critical, you should leave it unprotected so that the performance of the application remains intact.
Okay. The next question that we have here, this person would like to know, can code protection be used to protect shared libraries that will be included in other applications?
Yeah, so on iOS, there are no shared libraries. You only have static libraries, but you can still use code protection to protect those static libraries. On Android, you do have shared libraries, and yes, you can protect a shared library with code protection and distribute that shared library to other affiliates or vendors or whatever, and they will be able to use those libraries seamlessly.
Okay. What about protecting applications for other target architectures?
So like I pointed out here, when you create a new project, there is a custom platform, and you can basically, in our manual, we show you how you can use a special compiler proxy we have to integrate into your build chain, and this allows you to pretty much protect any platform out there. So if you don't see your platform listed here, you can use our custom platform feature to protect whatever platform you're running on.
Okay. What about integrity checking? Is that easy to circumvent?
No. So the way integrity checks work in our application is we actually insert hundreds of integrity checks. For example, in this Onions application, you will see that we inserted 149 integrity checks. And the way these integrity checks work is they all overlap. So each integrity check is not only checking the integrity of the application, it's also checking the integrity of the integrity checks themselves. So if the hacker were to go in and hack the integrity check, then all the integrity checks around it would detect the hacker's attempts to circumvent it and would prevent him from doing so. So the beautiful thing about the integrity checks is that they are all randomly generated. So each integrity check will be completely unique, and the hacker will have to go in and figure out each integrity check one by one. And if each integrity check takes like an hour or two to figure out, that's a lot of effort on a hacker's part in order to hack one application. A lot of hackers will just give up at this point.
Okay. And the next question that we have, this person would like to know, how do I use diversification?
Okay, that's interesting. So what happens is with Cryptanium code protection is that every time you obfuscate your application, we obfuscate in a different way. So like I said for the previous answer, we randomly generate integrity checks when we insert them into your application. We actually randomly generate every single security feature in our application. For example, every time you run the protection, your app will be obfuscated in a different way. It will have different integrity checks checking different parts of the application. It will have different anti-debug checking for a debugger at different times in the application. So as you deploy one version of the application to the next, the app protection scheme will be completely different. So if that hacker were to go in and spend a lot of effort trying to hack one version of your application, as soon as you upgrade your application, the hacker will be back to square zero. So we try to make it as frustrating as possible for the hackers, pretty much.
Okay. And the last question that we have time for today, this question is, how does code protection integrate into the development workflow?
So everything you see here is a nice GUI utility, but the fact of the matter is it's actually a wrapper on a bunch of command line utilities. So for example, if you have some sort of continuous integration setup or like you're using Jenkins, you can automate code protection in your build flow so that it automatically analyzes profiles and protects your application every time you check in a commit. Or so what I'm trying to say is everything here is a command line utility. Everything here can be fully automated as much as you like.
Okay, great. And if folks would like to learn more about Cryptanium code protection and Whitecryption, where can they go?
Just go to whitecryption.com, and we have free evaluations, so feel free to submit an evaluation request, and you can try out this utility and see for yourself if it works for you.
Okay, great. Well, I would like to thank Marco for taking the time to join us today. I'd also like to thank today's sponsor, Whitecryption, for making this event possible. And as always, thank you, the audience, for